The Physics of a Deadly Virus. Immune Response Research Hints to Answers to Fighting the Deadly Coronavirus. Brought to you by University of Washington and written by Ignacio Lobos. How do B cells engage with COVID-19? UW's Zach Montague was one of the principal collaborators on this joint research project between UW's Department of Physics, University of Hong Kong, and other institutions. B cells are constantly searching the human body for invaders, like COVID-19. Montague and his colleagues researched COVID-19 antibodies, blending biology and physics. They found a few dozen antibodies present in a group of COVID-19 patients that could lead to powerful new ways to fight the disease. This is a terrible disease, and we have to do everything we can to find every possible way to beat it, Montague said. Our results provide important insights into COVID-19, and our findings could enhance research and the development of effective therapies and vaccines against this disease. When so many lives depend on the outcome of research, speed becomes an essential factor of our work, Montague said. Montague is a PhD student specializing in the study of B cells and conducts his research as a member of Physics Assistant Professor Armida Noor-Mohammed's lab. They research the statistical physics of evolving systems. Statistical physics studies the behavior of large collections of interacting objects, such as atoms and molecules. Its reach has expanded into other areas of study, including biology, which offers a nearly limitless world of dynamic systems. The problem-solving mindset of a physicist is very useful in many fields, said Montague, who studied particle physics before coming to the UW. When I started looking at other fields for my PhD, I found out about Armida and her work with immunology, he said. Using physics to study the immune system makes for a very versatile and exciting field. I fell in love with the field of immunology, and I was completely enthralled by B cells and their role in an extremely complex immune system. We were literally looking for the needle in the haystack, but even more tricky because we are dealing with complex and dynamic systems, Noor-Mohammed said. Things are happening very fast with COVID-19, and it's amazing to have resources such as the HIAC to make this research happen. The work we accomplished so quickly was a huge team effort, and we couldn't have done it without HIAC, she said. The HIAC is UW's supercomputer that was used in Noor-Mohammed and Montague's research. I'm a physicist, but I also rely on the methods and software tools that you find in bioinformatics to understand biological data, Montague said. I work with nucleotide data, which means I have to do all of the work that biology people do, such as align sequences, match genes, and perform many other processes that take a lot of time and computing resources. HIAC allows me to do all this heavy work in a pragmatic amount of time. What used to be weeks and weeks of computation work, I can do in hours or minutes in HIAC, he said. There's a tremendous amount of variability in how we independently react to disease, Montague said. Understanding how our immune system adapts to fight a virus like COVID-19 may help us with the appearance of other novel viruses in the future. Thank you for listening to our presentation today on the physics of a deadly virus. Don't forget to subscribe to our YouTube channel. You can find us on Instagram and Twitter at UW Physics and on Facebook at University of Washington Department of Physics.